Hello people, thought I'd make a quick video because I haven't done one in a while. I've been working on some massive things which there will be videos of at some point, but I realised it had been a while, so I thought I'd better do one of these little side project things so that I'm putting something out. We're going to deal with this odd little piece of test equipment. I saw it like languishing on the net for like 20 quid or so. It's a vacuum tube voltmeter and some kind of signal tracer thing smashed together into one box. I work in a couple of spots around studio and workshop, so having two is not going to do any harm. It's quite convenient. This side is the vacuum tube voltmeter. It says Heath Company on the meter here, as in Heathkit, but it's obviously not a regular version, not least because it seems to be accompanied by some sort of signal tracer and the markings are all in German. 2-prong plug, so I'm guessing 240 volt European due to the German markings. Not opened this thing yet, so I have no idea on its internal condition, but I'm not holding up much hope after seeing that meter smashed on the front, which it wasn't in the photographs, but hey ho, no worries. So in case you're new to vacuum tube voltmeters, this is why we bother to use them. So you've got DC volts, AC volts, RMS and peak to peak, resistance measurements, a decibel scale, though that'd need to be really accurately calibrated to the correct 0 decibel reference to be of any use in a proper measurement. Then there's this odd looking tracer or some such thing which I have no clue about. As I said, I'm looking at this at the same time you are, pretty much. So quickly, why am I showing you how to fix and make what looks like antiquated test gear? And you're probably saying, some of you, surely it's been entirely replaced by modern stuff, which, well, no. There are quite a few benefits to owning and running a vacuum tube voltmeter. So if you can pick up a cheap wreck like this and do it up, there's some advantage to doing so, hence the video. The obvious things about a mechanical movement on an analog driven circuit is a speed of reaction to the input signal. So, you know, if you're trying to peak up a measurement or tuning circuits in a radio or checking potentiometers for fluidity and continuity, so why not use a regular analog meter? Well, the main thing is impedance, this type of thing. That would have, you know, 20,000 ohms a volt or 50,000 ohms a volt. So it pulls current from the circuit and therefore pulls the voltage down. So you have to kind of work out where you actually are because the reading is not accurate. With a vacuum tube voltmeter, of course, the impedance into the circuit is very high. So you don't have that effect on the circuit, and therefore the measurement is more accurate straight on the face of the meter. You don't have to do a quick bits of maths to try and work out what it actually is. And there's more reasons than that. Against a digital meter, most of which can go to say 40 megaohms, 50 megaohms in resistance readings, a vacuum tube voltmeter can often read 1 billion ohms. So, you know, 20-25 times higher than the better digital meters. And also a vacuum tube voltmeter will usually safely read 1,000 to 1,200 volts, which is higher than most digital multimeters, you know. And in AC measurements, digital meters are really only accurate up to a few hundred hertz, maybe a kilohertz or two. And these vacuum tube meters outdo that by quite a long way. And then finally, really, lots of old schematics give their measurements as you measured on a vacuum tube voltmeter. So obviously the best way to work out whether or not you've got the same thing that the engineer intended is to use the same type of meter to take the measurements as he did when he made those references on the schematic. So it appears, looking round it, scruffy thing that it is, that the only thing holding it in is this set of 4 bolts, one at each front corner. So we'll undo those and lift it out. So here it is in bits, and I really do mean in bits. Thanks to the delivery company. Again, excellent work. Circuit board's detached and broken. There's a smashed tube down there, loose wires, all the things. All the best things you can hope for. Not all bad though. The transformers look okay. The switches look unbroken, which is a real plus. They'd probably be the hardest thing to fix. Speaker looks okay, so we can save this thing. So I think the first thing we need to do is detach the power cable and these other cables so the chassis is easy to manoeuvre and we can get stuck in. And it's fairly easy to confirm that the 2 pieces of test gear within the box will be easy to separate. We've got mains coming in here, one side of which parallel feeds 1/2 of each respective transformer's primary winding through a fuse. The other half, I'm quite sure, runs round to the power switch, which then parallel feeds the other half of each transformer's primary winding. I sketched it out real quick so you can see what I mean in a theoretical sense. So the board that was broken in shipping was, of course, the vacuum tube voltmeter board. The meter and switches in front, of course, being the ones associated with that. These boards that are attached to the base of the unit are some sort of input filter. Possibly one or more as an oscillator, frequency generator of some sort. I really haven't bothered to pay much attention to that side of it, which will become obvious why. It's more use to me to have a simple tube signal tracer than all this stuff in here. So I think I'll renovate the tube voltmeter and I'll use what I can from the tracer side plus some parts from a spares box to make a simple signal tracer in this half. That way I'll actually use it on the bench. You know, the unit itself I think is a DIY job. I did look to see if I could find anything on it to no avail. So I think it's safe to say it's of no historical significance. So I've removed the meter so I can access everything better. I'm quite sure I can now remove all the vacuum tube voltmeter circuitry without actually disconnecting any one part from the other. Well, that's the tube meter circuit removed, ready for sorting. Let's get everything else removed now so we can see what we're starting with. Et voila, an empty casing. So I'm going to hunt through spares, see what I can find of any use, and get this case cleaned up. So I've found a few bits that I think will be a good basis for a signal tracer like this. I want to get the meter side sorted first, but I want to drill as many of the holes for things in this tracer side as possible before I reinstall the meter side. Hence the need to find these bits first, these critical bigger parts that will need mounting holes. So why these bits? Well, fairly simple. The power transformer, when you bridge rectify the secondary, gives out about 200 volts DC, and it'll let you take about 50 milliamps before it starts to struggle, so that'll be fine for this. The tube I chose because I can get a couple of 3 watts out of it at the couple of 100 volts of DC that I can get for the plate, or just a shade under. So I figured, well, you know, I don't really want any more than 2 or 3 watts for a signal tracer. I mean, most of the time what's going to be coming through it will be just a sine wave, some sort of beep, and I definitely don't want any more than a watt or two of that rattling around the workshop. So that'll be fine. And the speaker transformer came from an old record player, like a series filament, you know, cheap kind of thing from early 60s. The thing had been sat out in a barn and destroyed by pigeons, bats, rats and whatever else could get hold of it. So it was entirely destroyed. So I salvaged what I could from it, and this was one of those bits. Those UL84 tubes that those record players almost always have were 4K plate loads most of the time, or somewhere around that, into a 3 ohm speaker almost always. So I figured this speaker transformer will do quite well on a 5.5K plate load into 4 ohms. The maths works out roughly if you do it in your head or on a bit of paper, whichever you choose. And we really don't have to be all that critical about that kind of thing at this point, because, you know, there's always a range either side of the figures in these data sheets. You know, you get a figure somewhere near. If you don't want to sit around and do a load of complex maths, then plug it in, get it in a ballpark, plug it in, find out what happens and change a few bits. If you're in a rush, like I am with this project, that's also a good time to use that technique, because you can just sort of charge through it. So there we are. That's why I chose those pieces. So now we can work out where to put them. It's pretty tight but doable. I really can't spend much time on this project, so I've tried to compromise a bit on my OCD. The speaker sits up here. Mains transformer is at a right angle and off at one side. That's okay, even though the leakage from the transformer is worse from the corner than at any side. But I think we're okay at this distance. Out of the options, I think the output transformer is in a reasonable position there. Room still for switches under the speaker, and a main board with tubes on, etc. up here should just about fit. So a very brief explanation of how a vacuum tube voltmeter works. I won't go into much detail because it's not the point of the video, but simply the tube on the right is double triode. That's the meter tube, if you like. Now you feed a voltage to the grid of the first triode, and it causes the current to increase. And because of the way that the two triodes are set up, that causes the current in the other one to decrease, and that difference between them is pulled across the meter in very primitive terms, and the meter reads that current that's being pulled through by the imbalance in those two tubes. The tube on the left is just quite simply a rectifier, just 2 diodes to rectify AC voltage in order that it feed the meter circuit in the same way that the DC voltage does when that's directly input. Obviously the switches change the scale at which you're reading, and in very primitive terms that's about it. Put some double-sided tape between where the layers of insulated stuff here had separated, then superglued the crack. Now I've backed it with Gorilla Tape, and I'll cut off the excess and leave just enough to fold over this top edge. And next, of course, the broken circuit board. Now I could repair this corner if I was bothered for originality, but I'm not in this case, so I think I'll do it a quicker, lazier way. So we've got a silicon rectifier here, and to the top of this electrolytic cap, which needs changing anyway. So we just really need to make sure that the same things hook up to this trace here, and then to the other trace on the other side, and there we are. And of course the ground at the bottom. Here we are, I'm shining a light through so you can see what's happening more clearly. So we have a new diode and cap all hooked up. All I've really done is take the diode via a different route, via this orange wire. So now electronically the same and very quick in comparison to a proper repair. Okay, I'm going to give everything a bit of a scrub up, change any components that are out of spec of course, as this is a measuring device. I was very lucky with the shipping damage really, as I was left with switches that are completely fine, and that, as I said at the beginning of the video, would have probably been the toughest thing to repair or replace. Now it's important that the group of odd value precision resistors on these switch assemblies are all within a percent or two at the most of the stated value. And luckily all of these are. Not so with the ones on the board, but they're all standard values and much less fiddly to change, so that's far less of an issue. The only thing to change on the switch assembly really is this big electrolytic cap, which is this one. So it's a 0.047 microfarad cap at 1250 volts. Now, it doesn't need to be an electrolytic cap here. It's not necessary for it to be polarised in this part of the circuit. So I'm just going to use 200 nanofarad 630 volt caps in series, which is going to give me a 50 nanofarad at 1260 volts, or 0.05 microfarad at 1260 volts, if that's how you prefer to think of it. Right, I've started placing everything back in the case. That cap has been replaced. The arrangement for the battery was just too far gone to be safe, so in the spirit of getting it done quick and cheap, as it were, I made a replacement from an old solder tube. It's held in there with springs. You just pull out the yellow cap at the end there to change the battery. Secured to the bottom of the chassis with an old cable grip. So it's all, you know, as secure as it'll ever need to be. I've replaced this little fuse holder and put some new ceramic standoff tag things on there, as the old ones are swinging around everywhere and I was scared they were going to short on something. I've replaced a few resistors on this board too, so I think we're ready to fire it up with no tubes in and check we're seeing the right thing, voltages wise, you know. In the meantime, let me try find enough light to show you just how much of a monstrosity this case is. I'm not going to use £5,000 worth of equipment to sort this case, because most of you guys won't have that anyway, and well, neither do I. It'll be a paint stripper, steel wool and a spray can for this one. I don't want a handle because they just get in the way on bench gear. Also, I've no desire to keep these extra little sockets on the side, so I'm going to try and fill these holes. Again, I'll use a method that anyone can copy with simple tools. So I just glued a bit of scrap behind the holes and filled up the troughs with solder, after removing the old paint of course, and you know, rough sanded at the moment until I sort it out, but it'll look fine when it's painted. Right, so here's the schematic for the main circuit part of the signal tracer that I've come up with. Well, I say come up with, I've borrowed half of it. On the left hand side, that tube of 12X7 double triode, it's just essentially two preamplifiers, two small amplifiers to boost the signal up to the point at which the tube on the right, the EL90 at 6AQ5, is to amplify it into the speaker via the speaker transformer, of course. Now the input circuit is it's pretty much directly lifted from at least half of the signal tracers that I've worked on in the past. Again, I won't go through all the ins and outs of the circuit like that, because the chances are if you make one you're going to not find this exact tube in your spares box. So, you know, but I just thought I'd show you this in case you do have that tube. You could always copy this. You know, don't see any reason why you couldn't get enough from this schematic to do so. And the power supply, again, I'm just, throwing it together at this point. Is you just remember that this first resistor in the first filter here will take the current from everything, both of those triode sections on the 12X7 and the screen and plate of the power tube. When you're working out how big that resistor needs to be, resistance wise and wattage wise, bear in mind that it takes all the current from all of those things. The next resistor is to just drop down for the screen, and the next resistor is to drop down for the third HT line going to the top of both of those triodes, and also to the noise switch. Right, I'll keep this bit brief in an effort to get through this little side video. Okay, I don't want to, with this project, take the time to cover these gaps in the chassis and point-to-point wire this thing. It's not that kind of project. So I'm just going to chuck it on a couple of bits of circuit board. Ignore these two at the top, just thinking in progress. This is the power board, and then one for the tracer circuit to go on the back there. So I've moved that transformer after all to get it away from where the tubes will be. The two pieces of test equipment within this chassis will not be used simultaneously, so I'm not worried about having this power transformer nearer to the voltmeter circuit because it won't be on at the same time. Right, I'll go etch these boards and we'll carry on. I've quickly sketched out where the off-board parts connect. I wouldn't bother usually with something this simple, to be honest. I'd just chuck it together. But, in case you wanted to copy it or get any ideas from it, etc. Same for the power there. So here's the mains transformer for the signal tracer installed. One side of the mains straight to the transformer, the other side to the fuse, then to the power switch, then onto the other side of that primary winding on that transformer. So I've found some spare bits again. Remember, the whole point with this thing is to just make it function, but economically. It's got to be cheap to make it worth saving it, and I do want to save it. I don't like things going into landfill. Toggle switch there, mounted sideways, as I didn't really want to dock to the faceplate for the sake of turning a switch that way up. Found a couple of these insulated sockets and an old push to make switch for the noise function, so I can't accidentally leave that voltage on the probe, because when I let go, so does the voltage. Pot's all wired up as per the diagram, etc. So here's the input wired up, the 68k resistor to that noise switch. I'm using a switching jack to connect the speaker in such a way that I can defeat the internal speaker by just plugging in an external one, so I can use this circuit to test a speaker. It was a bit of a faff working out how to keep this power supply as far away from the high sensitivity input part of the circuit as possible. It's at a funny angle there because I haven't wired it up yet. I've opted to turn it upside down here above the power transformer. Obviously there must be room for the tubes and the speaker magnet. So although it looks like I have heaps of room, you can see from the way my hand fills the space that there's actually very little room there, so there'll be very little room left once all the tubes and the speaker are in. All the grounds are to one spot on the corner of the speaker transformer. The HT leads will run down and over from one side, and then all these signal wires back along this other side, so as far away from the power supply as possible. So the filament winding goes to that tag plate you can just see through the gap at the bottom, then up and held away, dropping down into the relevant pins, kind of thing. I mean, obviously fine to mount these tube bases on a board for something this low powered, etc., but I didn't really want to have the filament lines on tracers on the board, so I've done it like this. So everything in place. all relevant things kept away from other relevant things, etc. Time to wire up the speaker. There we are, speaker and tubes installed. Checked all the critical voltages, etc., and also calibrated this voltmeter. I won't go through all that now because this video is getting a bit long, and it's not the purpose of the video, and I don't really have the time. Right, time to get it in the case and see what it does. And there we are. A few bits to do in the future. When I've got more time, I'll fix up the meter case. I'll add a pilot light to the tracer circuit, as I didn't really have the time. But for now it's functional, which is all I needed, just an extra vacuum tube voltmeter for you know, entirely utilitarian purposes. And this one will be going in the workshop, and I'll stick my neater one in the studio, so it'll literally be almost always just me that sees this thing anyway. Just for confirmation, really. I know it's not very exciting. I've got the meter warmed up. It's been on about half an hour. I've got it set to DC volts on a 10 volt range, so we're reading off this 50 volt scale. So we're looking at the needle to sit just by 15 volts. Actually, the battery's a tiny bit flat, so I would imagine it's going to sit just under the 15 volt mark. Well, I hope it is. And there we are, just under 1.5 volts DC, when you're reading it correctly. How thrilling. And now, just a quick test of the tracer. I'm just going to pop a few hundred hertz or a kilohertz or something signal through and adjust the gain and volume. I've actually, the footage for this was all recorded a few months before I'm speaking now, and I haven't had time to compile it together and do anything with it. I noticed when I played the footage back that the camera, the microphone on it had become atrociously bad in terms of noise, and I felt that as an engineer I couldn't really justify having it that bad anymore. I shouldn't really have had it that bad on the first couple, but it just got worse and worse. It's a very old camera. So I'm going to away to the workshop and just record a little bit of video with it. This is, you know, 2 or 3 months later, the piece of equipment in my newer built workshop out the back, just to show you it functioning. Of course, it was the same back then as it is now, but I can't show you the footage from back then because you can barely hear the demonstration over the background noise. Hello, right, we're here in the newer workshop. So still a total tip. I'm just prototyping a new piece of equipment, so excuse all the mess. I've got this frequency generator set at a third of a volt peak to peak, so that's like 100 millivolts ish RMS. Excuse the wind noise, by the way. I think my shed's auditioning for the Wizard of Oz. So here's a signal tracer, been on the bench in use for months. Turn the gain up just there, you know, barely on really, and then as you can hear this, I'm going to turn the gain up a fair bit. Definitely loud if you're actually stood in here, it's awful. But you can hear, let me just switch all this right down, switch this frequency generator off, and then you can hear, get as close as I can. You can hear the speaker noise there. You see where the gain and volume controls are at now? You can hear very little interference and hum, considering the ground is now entirely wide open and not plugged into anything that's grounded. So the fact that it's barely audible still at that point, considering how we had to pack it all into that little piece of equipment, I think is it's not too bad. So there we go, a success, and now in permanent use. And there we are, another piece of junk saved from the landfill and turned into a functional piece of equipment. As I said, kind of a rush through with this one and just a functional job, but still probably a few pieces of useful information you might be able to glean from in it. Don't forget to like and subscribe if you enjoyed it. There'll be some far more interesting things coming very soon off the back of all the things I'm working on at the moment, but I won't say what just yet. If you want to find out, subscribe or just wait. So thanks for watching. See you again soon.